Today I'm going to be looking at the Year 8 Maths assessment on algebra, percentages, fractions, decimals, GST, percentage profit, etc. Look, it was a pretty tough test, to be honest. So I want to just go through question by question, because remember the role of an assessment is just to show us what you guys know and what you don't know. So it's to assist with your learning. So let's start with question 1. The average of the numbers 45.28 and 45.37. So look, to work out the average, what you do is you add the numbers together and then divide by how many numbers you have. So in this case we've got two numbers, so it's 45.28 plus 45.37 divided by 2, and that equals 45.325, and so our answer for question 1 is C. Question 2. Evaluate the expression w squared minus m squared if w equals 6 and m equals minus 2. So we substitute w equals 6 into 6 squared. Then we minus. Now, important to put brackets here. So we've got m equals minus 2. So we've got minus 2 in brackets and then squared. So negative times a negative is a positive. So that becomes 6 squared minus positive 4. So it's 6 minus 4. 6 squared minus 4 equals, well, that's 36 minus 4 equals 32. So our answer is B. The index number 10 to the power of minus 3 can be used to represent. Look, nice little visual way to work these ones out is just to make the little line that I have there, where I have 0 in the middle, and then I have 1, 2, 3, and on the other side negative 1, negative 2, negative 3. So we know that anything to the power of 0 is 1. So 10 to the power of 1 is 10. 10 to the power of 2 is 100. And 10 to the power of 3 is 1000. So you probably noticed a pattern there. Obviously, you're timesing it by 10, or if you go 3, 2, 1, you're dividing it by 10 to go backwards. So we keep doing that when we go to minus 1. 10 to the power of minus 1 is the same as 1 over 10. So we've gone from 0, which is 1. 1 divided by 10 equals 1 over 10. And it keeps going. Minus 2 is 1 over 100. And 10 to the power of negative 3 is 1 over 1000. So our answer there is C. Question 4. My video game high was 75 and it increased by 20%. My new high score is now. So look, it's increased by 20%. So important here that you know that 120% is the same as 1.2. So it's that working and movement between percentages and also decimals. So you can work out that simply by timesing 75 times 1.2, which equals 90. So our answer is A. Now, you can also kind of work that out in your head, because you know that 10% of 75 is 7.5. Therefore, if you're working at 20%, you're going to be doubling it. So that's going to equal 15. So 75 plus 15 equals 90. So look, there are a number of different ways to work it out. The number 4 over 17 rounded to 2 decimal places is, now you guys were allowed to use calculators, so you can simply plug that into your calculator and just write 4 divided by 17. And you'll get quite a big long decimal. Now it's asked us to 2 decimal places, and you'll see there I've actually written 3, 0.235, and that third place is the important one in this case, because what we're going to do is, if that is 5 or above, we then round up the previous one, and it's 5, so that means our answer is going to be 0.24. So look, I'd always encourage you, if it's 3 decimal places, look at 4, and again have that last decimal. That's going to be the critical decimal where you're looking at, is it 5 or above, and if it is, then you round up. So our answer there is 0.24, which is D. Question 6. An example of a recurring decimal is. So a recurring decimal is one that repeats. Now, this one is 5.7, and you can see the little dot above the 7. That means that 7 keeps going. So 7, 7, 7, 7, 7, 7, 7 indefinitely. So that means our answer is B. Question 7. An ice cream costing $4.40 before GST has 10% GST added to it. The cost is now. Okay, so again we could have 440 times 1.1, which is going to give us $4.84. Or again, this is one you can probably do in your head. What's 10% of 440? Well, that's 44. So you add $4.40 to 40. You add 44 cents to $4.40, and you're going to get $4.84. Question 8. Which of the following is or can be written as a recurring decimal? So look, you can plug all these ones in. Definitely not 9 to the 0 because that equals 1. Pi, hopefully you know that doesn't repeat, or at least it takes a long time before it does. You can plug in the square root of 3, and you come to 7 over 22. And if you simply divide 7 divided by 22 into your calculator, you're going to get this number where it goes 0.3181818, meaning obviously that the 1 and the 8 are occurring. So again, we just put our dots over the 1 and the 8. So our answer there is A. Question 9. 6pq divided by 24pr. So look, I know that's division, so I can write that out as a fraction, which is exactly what I've done, and then I start cancelling. So I've cancelled 6 and p from the top. So if I divide by 6 and p down the bottom, I'm going to get, leaving q up the top, over, so 24 divided by 6 is 4. I can cancel that p, so I've still got an r. So the answer is the answer is q over 4r, and therefore our answer is B. Question 10. My weight was 70 kilograms and 45 grams. This is the same as. Now look, the trick to this one is in the kilo. What does kilo mean? Well, it means 1,000. So if you think of kilometers, there are 1,000 meters in a kilometer. Now this is the same with kilograms. There are 1,000 kilograms. There are 1,000 grams in a kilogram. So that means that the 45 grams, to write that out as a decimal, is going to be 45 divided by 1,000, which is going to equal 0.045. So we've got 70.045, and our answer is B. So that was, again, you needed to know the language and think about things like kilo. Think of kilometre, kilojoule. Always means that there's 1,000 joules in a kilojoule, 1,000 grams in a kilogram. Okay, question 11. Simplify 3 to the power of 11 times 3 to the power of 5. Look, that's our index notation shortcut. So remember, when we're multiplying them out, we can add the indices. So that means that 3 to the power of 11 times 3 to the power of 5 equals 3 to the power of 16. And look, something that you can do there is just like write it completely out. So 3 times 3 times 3 times 3, and you do that 11 times, and then it's times 3 to the power of 5, which is 3 times 3 times 3 times 3 times 3, and all those 3's, if you add them all up, there are 16 of them. So that's how you can kind of expand it out and see that that works. Now, Bob answered question 8 incorrectly. Give an example of one incorrect answer he might have given and state what he did to get it wrong. Well, look, I've gone for 9 to the power of 16. And what he did incorrectly is he multiplied the base as well as adding the indices. And you can see how easy that would be to do. But again, going back to that kind of expanded form where it's 3 times 3 times 3 times 3, 16 times, you can see that you don't multiply the base. What it means is that's 3 times 3 times 3, so the base stays the same. Question 12. Fully simplify the following expression. So we've got 4m minus 2mn plus 5mn minus m. Look, this is going back to adding and subtracting like terms, so you can only add or subtract like terms. So that means that you've got to find the like terms first, and that's what I've done here. I've circled the m's. So we've got 4m minus m, and then I've underlined the other like terms, which are the m and the n. So we've got minus 2mn plus 5mn, and what that works out to be is 3m plus 3mn. Question B, 18pq over 12p squared. So again, we're very simply crossing things out. So if it's at the top and at the bottom, we can get rid of it. So I know that 6 goes into both 18 and 12. And there's also a p at the top and there's a p squared at the bottom, and p squared means p times p. So I can cancel those there. So I can cancel a 6p, which leaves me with 3q at the top and 2p at the bottom. So it's 3q over 2p. C, 3cd minus 9 minus 12cd plus minus 8. So again, we've got our like terms, which I've circled, which is the 3cd and the minus 12cd. And then I've also got the like terms of minus 9, and there's a plus, and then minus 8 in brackets. So that's just going to equal minus 8. So we've got 3cd minus 12cd. Well, that equals minus 9cd. And then minus 9 minus 8, that equals minus 17. D, ab squared c cubed times a squared b. So we've got a squared times a, and that equals a cubed. Then we've got b squared times b, and that equals b cubed as well. And then we've just got c cubed out there on the left, so that stays the same. C cubed, so our answer is a cubed times b cubed times c cubed, and obviously you can put all those in, you don't need to have the multiplication signs in between. Question 13, fully simplify each of the algebraic expressions. So 3z over 5 plus z over 5, so that's pretty easy. You've got a denominator that's the same. Remember, you have to have a denominator that's the same to add. So that's going to be just 3z plus z equals 4z over 5. B, so we've got 5k over 6 minus 3k over 4. So we can do our little cross multiplication to try and make our denominators the same. So that would mean that it's 4 over 4 times 5k over 6. So that equals 20k over 24. And that's minus 3k over 4. And we're going to times that by 6 over 6 to get the denominator the same. So that equals minus 18k over 24. So it's 20k over 24 minus 18k over 24. So we can simplify that down to 2k over 24. Now 2 and 24 are both even numbers, so we can divide that by 2. So we're left with k over 12. C, 7f over 8 times 4f over 3. So we multiply the top first, so it's 7f times 4f, so that's going to equal 28f squared. And then we multiply the bottom together, and that's over 24. We know that 4 multiply into both 28 and 24. So it's going to leave us at the top with 7f squared, and at the bottom over 6. So our answer is 7f squared over 6. E. D. So we've got 10y over 9 divided by 5y over 6. Now remember, whenever you see the division with a fraction, the way to do that is you invert it. So we're left with 10y over 9, and we do our inversion, so we turn to a multiplication, and that becomes 6 over 5y. Now look, you could cancel the y's there because you can see that there's one at the top and one at the bottom. I've put them into the next step, 60y over 45y. So you can move that along to 60 over 45. Now look, I know that that multiplies into 15 both times. You could potentially go, I think multiplies into 5 both times, but I'm going to go straight to the 15, leaving me with 4 over 3. E, 12f minus 4 times 3f. Again, a little bit of a trick question. You always have to remember that you multiply first. Okay, so we've got minus 4 times 3f, so that equals minus 12f. So we have 12f minus 12f, which equals 0. Okay, f, bc over 7 divided by 2b over 14 minus c. Okay, so first thing we'll do is we'll do our little inversion. So it's bc over 7, and then we'll invert, which means it's 14 over 2b minus c. Okay, so when we put all that together, we come out with 14bc over 14b. Now, the 14 and the b are both at the top and the bottom, so we can cancel them, leaving us with c minus c, which equals 0 as well. Question 14, expand and simplify. So we've got 4 bracket 3n minus 11 close bracket. Now we have to remember with the 4 out the front is you have to multiply by both the first part and also the second part. So we start by multiplying 4 and 3n, so that's going to equal 12n, and then we multiply 4 and minus 11, so that's going to equal minus 44. So our answer there is 12n minus 44. We do the same thing to b. So it's minus 6 times 8, so that equals minus 48, and then minus 6 times minus m. So remember, when we multiply two negatives together, we come out with a positive, so that equals plus 6m. So our answer there, we'd probably turn it around and go 6m minus 48. C. Okay, so we've got 4p out the front, bracket 2p plus 3. Okay, so 4p times 2p equals 8p squared, plus 4p times 3, so that equals plus 12p. And then we've got minus 2 times 7, so that equals minus 14. Then we've got minus 2 times minus p squared, so two negatives become positive, so it becomes plus 2p squared. Now our only like terms there is the 2p squared, so we've got 8p squared plus 2p squared, so we've got 10p squared, then plus 12p minus 14, and that's our answer. Question 15. For the expression 5y minus 8z plus 12, find the coefficient of z. So remember, the coefficient is the number out the front of z. Okay, so that equals minus 8. Important to make sure you put the negative in there. The constant term, okay, so that doesn't have a numeral. So the constant in this case is plus 12. C, y equals minus, if y equals minus 4, what value would z have to get to give an answer of 0? Okay, so we plug in 5y, so it's 5 bracket minus 4 minus 8z plus 12, and the answer has to equal 0, so we've got equal 0. So we can expand that out now to go minus 20 minus 8z plus 12 equals 0. Okay, now minus 20 plus 12 equals minus 8, so we've got minus 8z minus 8 equals 0. Okay, so we can get the 8z over to the other side, so we've got minus 8 equals 8z, so we're adding 8z on both sides, and then we just divide by the 8, leaving us with z equal to minus 1. Question 16. Factorise each of the following fully. So got to remember that factorising is the opposite of expansion. So 30b plus 20. Okay, so I can see that 10 goes into both. So we've got 10 outside the brackets, and then bracket 3b, because 10 times 3b equals 30b, and then plus 2, close brackets, because 10 times 2 equals 20. And if you just want to check it, then just expand it back out, and it should equal that initial number. That's the way to check it. Okay, 15s squared minus 25s. Well, they're both 15 and 25 go into 5, and both sides have s's. So 5s I'm going to stick out the front. So that's bracket 3s, because 5s times 3s equals 15s squared. And then it's just, I put a minus 5 in there, because minus 5 times 5s equals minus 25s. C, minus 8pq minus 4p. So I know that in minus 8 and minus 4, we can have minus 4 as a common factor. Now both sides also have p, so I'm going to have minus 4p out the front. So that's going to be bracket 2q times minus 4p equals minus 8pq, and then it's plus 1, because 1 times minus 4p equals minus 4p. Question 17. Simplify each of the following, leaving your answers in index notation. So we've got 5 squared times 5 squared, so remembering our index notation shortcut, we can add the indices there, so that equals 5 to the power of 4. B, x to the 13 divided by x to the 9. So what we can do there is subtract. So it's 13 minus 9, so we've got x to the power of 4. Now we've got brackets 6 to the power of 4, and outside the brackets we've got 5. Now, one of our shortcuts there is we multiply them together. So what that would mean if we expand it out, this is 5 brackets of 6 to the power of 4. So 6 to the power of, so 4 times 5 equals 20, so it's 6 to the power of 20. Okay, D, y to the power of 0, well that equals 1, plus 2 times y to the power of 0, well 2 times 1 equals 2, minus y to the power of 0, which equals 1, plus y. So what we end up there with is 1 plus 2 minus 1 plus y. So 1 plus 2 equals 3, minus 1 equals 2 plus y. So it equals 2 plus y. And then look, if you're going to put your index notation, it's to the power of 1 plus y to the power of 1. Okay, question 19. Write the answer to 39 divided by 43 as a decimal rounded to 3 places. Okay, so again, I just plug that into the calculator and it comes out, spits out a number, and I've got 0.9069. So again, you can see it's asking me to round it to 3 places. What I've done is I've looked at 4, so that fourth digit is going to be the critical one, which is 9, which is more than 5. So I'm going to be rounding up. So my answer equals 0.907. So write 0.875 as a fraction in its simplest form. Well, I know that with that as a fraction, that is the same as writing 875 over 1,000. So what I've done there is I've then divided that fraction on both sides by 25, 25 over 25. Okay, which gives me 35 at the top. So 35 times 25 equals 875, and it gives me 40 at the bottom. Now, both 35 and 40 can be again divided by 5. Okay, so that's going to give me 7 over 8. I think that's going to be as simple as I can get it. So the answer is 7 over 8. Okay, so it's right 7 over 9 as a recurring decimal. So again, I will just divide 7 and 9, which is going to bring up 0.77777, etc. So I just write 0.7, put the dot up above to show that it's recurring. Using the method of division, not your calculator, write 2 over 11 as a recurring decimal. Okay, so you can see I've done the long division there. I've got 11 and then 2, and because you can write 2 as a decimal of 2.0000, that's what I've done. Okay, so 11 doesn't go into 2 at all. It does go once into 20, so I've got my 0.1, and that leaves me 9 left over. So I can go 11 times 8 equals 9 equals 88, so that's going to be as close as I can get. Okay, so it's leaving 2 left over, so it's 0.18, and then you can see we starts to recur, because we're going to have 20 again, then we'll have 8 again, then 20, 20, and then 9 will be left over. So it's going to just be continuing going 0.181818, so we can put the dots over the 1 and the 8. Question 21. On a recent science test, Usain scored 38 out of 51, and on a recent maths test, Gary scored 68 out of 92. Who scored a greater percentage on their test, and by how much? Well, look, to work out Usain's percentage, you're going to divide 38 by 51. That equals 0.745, so that's the decimal. So we can convert that to a fraction, to a percentage. It equals 74.5%. Okay, and we can work out Gary by 68 divided by 92, and that equals approximately 0.739 or 73.9%. If we just subtract those two together, we come up with 0.6%. So Usain had the best percentage, and it was by 0.6%. Now, there were 84 robberies. Question 22. There were 84 robberies in Orange in January, but the number of robberies increased by 25% in February. So again, that relationship between decimals and percentages, we can times 84 times 1.25. And in doing that, the answer comes out to be 105. Again, probably a way you could do it in your head is you know that 25 is the same as a quarter. well, you work out what a quarter of 84 is. That equals 21, and so then you would just add 84 and 21 and you would get 105. So just two different ways to kind of work that out. The price of petrol on the weekend was $1.30 a litre. On Tuesday the price dropped by 15%, but then went up again on Thursday by 15%. What was the price of petrol to the nearest cent on Friday? So it's $1.3 times 0.85, because the price has been dropped by 15%. So that's 85% is the same as 0.85. And then we multiply that number by 1.15. And it's going to work out to be 1.27 litres on Friday. Question 24. Earrings were priced at $59 before the GST of 10% was added. What was the sale price once the GST was applied? Well, we can times 59, that's currently at 100%, but we've got to add another 10%, so we can multiply that by 1.1, which is going to work out to be $64.90. Again, you could just work out 10% and go, right, 10% of 59 is $5.90, add $5.90 onto $59, and again you get $64.90. So two different ways to do that question. A new phone costs $485 to purchase, which included the GST of 10%. If I were able to buy this phone GST free, how much would it cost me? So what we know is that $485 equals 110%. We know that 110% equals 1.1. So therefore, to get to 100%, we can divide 485 by 1.1. Okay, and that is going to equal out to be $440.91. Question 26. I bought a ticket to the Adele concert for $200, but I couldn't go. I sold it to my friend Kanye for $240, so what was my percentage profit? Well, firstly you work out what your profit was, which is $240, which is what you sold it for, minus $200, which is what you bought it for. So that's giving you $40 profit. And then to work out the percentage profit, you have that $40 and you divide it by the initial price that you paid. Okay, so it's $40 divided by 200, and that equals 0.2, which is the same as 20%. So you made 20% profit. Okay, question 27. I paid $8 of the restaurant bill for our table. I paid 8% of the restaurant bill for our table. If I paid $52, how much was the total bill? Well, how I'd first work this out is I'd work out 1%. So 8% equals 52. So if I divide that by 8 to get 1%, it equals $6.50. Now I want to work out 100%. So I'm going to times that $6.50 by 100. That gives me 100%. And the amount equals $650. So the total bill was $650. Question 28. At the Athletics Carnival last week, Bob, Susan, Igor threw the discus. Using laser technology, the top three distances were measured accurately like this. Bob 41 meters and Bob 41.284 meters, Susan 41.302 meters, and Igor 41.295 meters. So rank the athletes in descending order according to the above distances. Well, descending means that you put the highest first. So that's Susan. She threw the greatest distance, so 41.302. The next greatest distance run was Igor, 41.295, and then Bob, 41.284. The second part of the question, as the results came in, the event manager said we only record the distances to the nearest tenth of a metre, and then we give out the medals from there. Now the tenth of the metre is the first decimal. Okay, so it's the same as saying to one decimal place. So it goes tenth, hundredth, thousand. So if it was asking you for a hundredth, it's asking you to two decimal places. If it's asking you to the nearest thousandth, then it's going to be three decimal places. Now, what happens then if it's ranked in this way is that they all throw 41.3 metres. Okay, because Susan's on 41.302, so that's not high enough to be rounding up, so it stays as 41.3. Now, Igor threw 41.29, so straight away that's going to be rounded up to 41.3, because the 9 is, if it's 5 or above, then you round up. And it's exactly the same for Bob. He threw 41.28. 8 is more than 5, so that will round up again. So they all get a gold medal. Question 29. Find the simplest answer for the expression. Okay, so we've got lots of brackets going on. So square brackets and then parenthesis, round brackets, 3x squared, y cubed, and then round brackets to the power of 3. Okay, so what that means is it's going to be 3 times 3 times 3. Well, we've got those brackets 3 times. So there's going to be 3 in one, then another 3 in the next one, another 3. So 3 times 3 times 3 equals 27. And then remembering our index notation shortcut, it is x squared, and we times the two indices. So it's going to be 27x to the power of 6, and then it's going to be y to the power of 9, divided by 9x5, and then we've got round brackets y squared, and then outside of those round brackets we have squared again. So that's going to be 9x5 y4. So again, we just go through that cancelling kind of process. You know that 9 goes into both the top and the bottom. So that's leaving us 3 at the top. We've got x6 over x5, so we can cancel out 5 of those, leaving us with 1x. Then we've got y to the power of 9 over y to the power of 4. So we can cancel 4 of those y's, leaving us with y to the power of 5. So our answer equals 3xy to the 5. Question 30. Write your own original word problem. See question 21 to 28 for suggested questions and style, using decimals, fractions, percentages, GST, or anything else you may have studied for in this assessment. Well, I'm a bit of a rugby head, so I'm going to do a rugby question. So over a rugby season, Angus converted 47 goals and missed 12 goals. Work out his success rate as a percentage. Okay, so he's converted 47, so it's 47. Now it's over 59 because you have to add his successful conversions and his unsuccessful conversions together. So it's 47 plus 12. So we divide 47 over 59 and we get a decimal, so it's 0.797. Now we can convert that into a fraction, that is 79.7%. So Angus is kicking pretty well. And that's it, that's the end. So look, hopefully that's been helpful. What I want my students to do is any questions that you got wrong, you need to go back to the book, find where that question fitted, what chapter, and find 2 questions that are like it, and then complete those 2 questions and make sure you get them right. Work out what it is that you didn't understand, or potentially it was a silly mistake, but what was the reason why you made the mistake and didn't get it correct in the assessment. So use the assessment for learning. That's the goal. Anyway, thank you for listening, and yes, I'll make another video for you very soon. Thanks so much for watching.